As we look at differential equations, we're going to start out with one of the easiest forms, and we use the method of separation of variables to be able to solve these. Now, these differential equations come in a specific format where you have your derivative on one side and you have a ratio of functions on the other side. And if I take and do the cross product, I'm going to get all my y's, my dependent or my independent variable y on one side, and I'm going to get an independent variable x on the other. It's very important that it comes into this form where all the y's in this case are on one side and all the x's are on the other. Now, if I want to solve this, then I just take the integral of both sides. And I can come up with a solution. So let's take a look at the problem in the notes. Have dy over dx is equal to sine x times tangent y over cosine x. And if I do the cross product, I'm going to get sine x over cosine x is equal to, I'm sorry, forgot my dx here. Don't want to forget that. Is equal to dy over tangent of y. And this sine over cosine right here can be changed into a simple or a more simple function, and I can do the integral. So it's going to be the integral of the tangent of x dx is equal to the integral of dy over tangent of y. Now I can look these integrals up in the integration table, and I'm going to find that this is the negative natural log of cosine of x. And we could have actually gotten this through substitution if we wanted to do that. And the other side is the natural log of sine of y. Now, because I'm doing undetermined integrals, I need to remember to add a constant here. Now I should simplify this because I really want to get y in terms of x. So remember the law of cosines. If I have a negative, that just means that it's the logarithm of the reciprocal. So I can change this to the natural log of 1 over cosine x is equal to the natural log the sine of y plus c. Now I can't just get rid of the natural logs because I have this c, this constant here. So I'm going to have to take both sides and raise it e to the power of these. And when I do that, the e to the ln of 1 over cosine of x, and just to write here just so that you understand what I'm doing, if I do e to the natural log of x, that would equal x. So if I take and raise this on both sides, and I'm just going to write it here. I'm going to put the e here and the e here, and I'm going to make sure that I put those in brackets so that you see. Now this is just going to come out as 1 over cosine of x, and that's going to equal on the other side, well, I'm going to have e to the ln sine of y, and I'm going to use the law of exponents, and I'm going to have e to the c. And that's because, remember, a to the x times a to the y is equal to a x plus y. So I'm just going from this right-hand side to the left-hand side. And now I can simplify this down, getting rid of the e and the natural log combination here. Now e to the c, that's just some constant. So I can simplify this and just make this e to the c some constant c1 times the sine of y. And now if I divide both sides by c1, I get sine of y is equal to 1 over c1 cosine x. And then I just have to take the arc cosine of both sides. And there's our final answer. Now, these problems, though they look fairly simple, because this seems to be fairly simple here, may not be as simple as you can see from this problem. It requires a little bit of work, but they are the easiest to set up. And so you should be able to do these types of first order differential equations. We're going to be using these quite a bit this semester to derive some different functions or different systems and their solutions. And so it'll be good for you to understand how to do separation of variables.